There are a few properties that we should know about in order to be able to solve equations. The first is called the reflexive property. The reflexive property, says that something is equal to itself. The symmetric property says that if A is equal to B, then B is equal to A. So for example, 1/2 is equal to 0.5, then we know that 0.5 is equal to 1/2. And then the transitive property says that if A is equal to B and B is equal to C, then A also has to be equal to C because they're both equal to B. And then lastly, the substitution property says that if A is equal to B, then you can replace A with B and vice versa. So we use the substitution property a lot in algebra. So we're going to look at solving some equations today. Solving an equation that contains a variable means finding all values of the variable that makes the equation true. Such a value is called the solution. So when we find the value of the variable that makes the equation true, then we are finding the solution to the equation. So we're going to work some of these together. We're going to start with number 2. We're going to start with number 2, and we see that I've got a variable on both sides. These shouldn't be too difficult for us. These are all Algebra 1 equations. They're called linear equations. So the first thing I'm going to do is I'm going to subtract 4n from both sides. Can I subtract 12n from both sides? Absolutely. But I like to keep the coefficient in front of the variable positive. So I'm going to subtract 4n from both sides and leave the 21 on the right side. 12n minus 4n we know is 8n. And then I'm going to add 3 to both sides to get n by itself. So I see 8n is equal to 24. And then I'm going to divide both sides by 8, so I get 3. The next one, I've got some fractions here. So sometimes fractions freak me out a little bit. So we want to make sure that we know that we can put these fractions in our graphing calculator pretty easily. So the first thing I'm going to do is I'm going to subtract 1/3 x from both sides. I see I have a variable on both sides. So I'm going to subtract 1/3 x from both sides. So I get 1/4 is equal to, and then I know that 1 minus 1/3 is 2/3 times x minus 1/6. And then I need to add 1/6 to both sides. So I need to do 1/4 plus 1/6. So if this is not something that I'm comfortable with, then I always know that I have my graphing calculator that will do this for me. I have to add 1/4 plus 1/6. So I'm going to know that I can put in my fractions 2 different ways. I could use the parentheses and do 1 divided by 4 and close parentheses. This is 1/4 in our calculator. So 1/4 plus, and then I'm going to do 1/6. And if I put it in like this, it was 1/4 plus 1/6. I'm just making sure. I can put it like this in my calculator, and when I get my answer, it's going to give me my answer as a decimal. So the way that I change my answer back to a fraction is I want to go to the math button, which is right below the alpha, the green alpha key. So the math button, number 1 says arrow and then frac. So that's going to change our decimals to fractions. So I'm going to press enter, and it's saying I'm going to change my answer to a fraction. So I'm going to press enter, and it gives me 5/12. The other way that I can enter fractions into my calculator is I've got a shortcut on the F1 button. The F1 is the alpha on the y equals. So all the way at the top, I have the F1, the F2, the F3, and the F4, and the F5. So I'm going to do alpha F1 for y equals. And then number 1 is numerator over denominator. That's the button that I want. So I'm going to press enter, and it makes it a fraction for me. So I'm going to do 1, and then I'm going to do down arrow, and then 4 to the right, plus, and then I'm going to do the F1 button again. So I'm going to do alpha y equals, numerator over denominator, 1, and then I'm going to go down 6. So there's 1/4 plus 1/6. Move your cursor to the right by pressing the right arrow at the top. And then when I put my fractions in as fractions rather than division signs, then I get my answer as a fraction. So you can choose whichever way you'd like. It doesn't matter. So you can practice that. We're going to have lots of time to practice that this year. Okay, so the next thing I'm going to do is I'm going to divide both sides by 2/3, but I don't ever want to divide by a fraction, so I'm going to multiply both sides by the reciprocal, because I know that 2/3 times 3/2 is 1. That's the, remember from yesterday, that's the multiplicative inverse property. And then I'm going to multiply 3/2 times 5/12. So I'm going to go to my calculator. I'm going to practice putting in my fractions. 3/2, 3/2 times alpha y equals again 5/12, and it's going to give me my answer as a fraction. Already reduced, which is really good also, 5/8. So I get 5/8, and I'm done. Okay, let's move to number 6 now. Number 6, it says find the dimensions of the rectangle whose dimensions are shown. So what we need to know is that the area of this rectangle is 304. So I'm going to set up the length times the width is equal to 304. And I know I need to distribute here. So I'm going to distribute 14. 14 times 10x is 140x. Minus, I don't know 14 times 24 off my head. So I'm going to do 14 times 24. And I'm going to get 336. And then I'm going to add 336 to both sides. I need to erase. And that is 336 plus 304. Plus 304, and that is 640. So I get 140 times x equals 640, and I'm going to divide both sides by 140. And I get about 4.57. Okay, so now I'm going to skip 7, and I'm going to keep doing the evens, and I'm going to go to number 8. Okay, number 8 looks like we have some like terms to combine. I see 11 minus 7 on the left side, so I'm going to write that as a 4. And I see on the right side, I see 6x minus 3x, which I know is 3x. Okay, and then I still have variables on both sides. So I'm going to subtract 3x from both sides to combine those like terms. And when I do that, I want you to notice that all the variables go away. So the rule is, we know that when all the variables go away, then our answer is either that there is no solution or there are infinitely many solutions. And since this is a false statement, 4 is not equal to 5, then I know that means there is no solution to this equation. And what that means is that no matter what number we try to put in, it will not make the sentence true. So once more time, if all our variables go away and we get either a true statement or a false statement, then if it's a false statement, then that means there is no solution. Or if it is a true statement, then we want to say that there are infinitely many solutions. Any number I plug in would make the sentence true. All right, so the next thing we're going to do is we're going to solve for the indicated variable. So these equations have more than one variable in them, and we want to solve for a specific variable. So for number 10, we want to solve for h. So in order to solve for h, I need to multiply both sides by 2. I'm going to write this a little bigger so we can see. And I'm going to multiply both sides by 2, because 2 times 1/2 is 1. And we don't want to divide by a half, because we don't ever want to divide by fractions. And the last thing I have to do is divide both sides by b. So I get that h is equal to 2 times a divided by b. Notice my answer is not a number. it's an expression that has variables in it because these equations have more than one variable in it. Okay, let's go down to number 12. We're solving for x. Okay, so the first thing I want to do is add 5 to both sides. So I get x over a equals b plus 5. And then I want to multiply both sides by a. It says x divided by a, so I want to multiply both sides by a to get rid of that divided by a. So we get x equals b plus 5 times a, and if you'd like to distribute, you may, or you don't have to. Okie dokie, so you're going to try 11 and 13, but for now we're going to move on to 14. Solve each equation for x. So these are a little more challenging, so that's why they're in a different section. So let's see what we've got here. I noticed that there's an x here on the left side, and I also noticed there's an x here on the right side. So I see that the x appears in more than one place, so that's going to make it a little bit more difficult for us to handle here. So the first thing I think I'm going to do is I'm going to distribute. Okay, so I get c times x would be cx, and c times 2 would be 2c. And I'm going to distribute my b. So I get b times x minus 3 times b. Okay, so I'm solving for x, and I see that it's still on both sides. So what I want to do is I want to move every term that has an x on one side of the equation, and every term that does not have an x, move it to the other side. So I think what I'm going to do is I'm going to subtract cx from both sides. So I get 2c minus 5 is equal to bx minus cx minus 3b. And then I need to add 3b to both sides to get rid of that minus 3b. So I get 2c minus 5 plus 3b is equal to bx minus cx. So what I've accomplished here is I have gotten every term that has an x, whatever I'm solving for, has an x on one side and everything else on the other side. And so the last thing I want to do, I'm going to move it over here. I'm going to move it over here to make more room. So I've got 2c minus 5 plus 3b equals bx minus cx. So I've got these two terms that have an x, so they share something in common. They have an x in common. So what I'm going to do is I'm going to factor out that common factor. That's something we learned in Algebra 1, factoring out a common factor. So we're going to factor out that common factor, and when I factor out an x, I'm left with b minus c. And now I see, instead of the x appearing twice, it only appears once. So I can divide both sides by b minus c. It says x times b minus c. So I'm going to divide by b minus c, and I have solved for x. It's kind of complicated, isn't it? Let's try that one more time. Okay, so the next one, I think number 16, we've got, let's see, we're solving for x, and I see the x appears twice again. So I think what I'm going to do is, I don't like these fractions. So the first thing I'm going to do is I'm going to multiply the whole equation by 5, and what that's going to do is that's going to get rid of those fractions. So 3ax divided by 5 times 5 would be 3ax. And minus 4c times 5 would be 20c. And then I'm going to multiply ax divided by 5 times 5, which is just ax. So now that looks a lot better. That looks a little more like the last one, but we still see an x on both sides. So I'm going to move all the terms that have an x on one side and all the terms that don't have an x on one side, on the other side. So I'm going to subtract 3x from both sides. And I have negative 20c is equal to ax minus 3ax. And once again, I'm left with these two terms that both have an x, so they have a factor in common. They have an x in common, and I know that they have an a in common also, but I'm not worried about that a because that's not what I'm solving for. I'm solving for the x, so I'm going to take out the x. I'm going to factor it out, and I'm left with a minus 3a, which now, if you notice, becomes like terms. 1a minus 3a is negative 2a. So now in order to solve for x, I need to divide by negative 2a. And I'm going to always make sure I reduce my fractions. So when I see negative 20c divided by negative 2a, I know that negative 20 divided by negative 2 is 10. So I'm going to say 10c over a. And I'm done.